Good afternoon, class. I'm Mr. Precella, and today I'm with my college algebra class, and we're going to be looking at zeros of polynomials. But
I should have called it zeros of polynomial functions instead of polynomials because everything's functions now.
okay, but what we're going to start off with, y'all may or may not remember long division, polynomial long division, and
you may not remember how to do it, but most people remember.
When they see
yeah,
I remember this
that.
stuff. Okay, most people do. This doesn't show the way you have to draw the line and change the sign, but it's a pretty good example of polynomial long division. And first, I think we should make sure that we all remember the terminology for polynomial long division.
Well, for any sort
of division. And there's generally three accepted methods of representing division. Just the standard old division bar. The thing that's being divided is the dividend. Dividend divided by divisor.
Do you remember what the answer to a division problem is called?
What's the answer to a division?
Starts with a key.
Quotient. Good. Now, another way of expressing the operation of division is through the use of a fraction bar. In that event, it would be dividend on top, divided by the divisor.
And that division bar, that fraction bar could be a slanted bar.
Is equal to the quotient. And then there's that polynomial long division symbol. I guess it's the same symbol as you use for integer long division. The long division sign, the thing underneath the division bar, that's the dividend. The thing that's doing the dividing is the divisor. And the answer, oh, I forgot to turn on that thing. Oh, there it is. Okay, y'all, is the quotient.
But since you have it written like that, you could show one other word. Draw the equal sign and what goes at the bottom.
Oh, yeah. What goes down at the bottom?
Sometimes it's zero, but sometimes it's not.
The remainder.
So we're going to be doing a lot of division today.
We're going to start off with the shortcut for polynomial long division. Here's an example. As I think we already showed you that picture. Let's see, where is it? There it is. The polynomial long division. For our purposes, there's a shortcut called synthetic division. You're not going to have to go through polynomial long division at least. So synthetic division it is a shortcut for long division, but it only works when the divisor is in the form x plus or minus some constant k.
Why don't you write number instead of k?
Okay, I'll write it like this. X plus or minus a number. Now that number there is what I'll be denoting with the letter K. Synthetic division is a very nice shortcut for polynomial long division, but it only works when the divisor is first degree. You can't have an x squared in the divisor. You can't have a coefficient in front of that x. It's just variable plus or minus a number.
Let's see, look at this picture. Is this one that...
Could we use synthetic division for that? Look at that divisor. The divisor is x minus 3. Is that one that we could use synthetic division with? Yes, because it's just variable, and in this case, a minus 3. Let's use synthetic division to divide There's really no way to explain synthetic division without looking at an example. So we have, let me write it down, 2x squared.
No, 2x cubed.
No, it isn't. It's a 2x squared.
I thought you were writing the whole.
Oh, yeah, 2x cubed. Oh, my Lord. 2x cubed minus 5x squared minus 8x plus 15 divided by, wait and let me write it down on the paper and then you'll see how I'm writing it. I don't use that long division symbol. That thing is not really conducive to algebra. So 2x cubed minus 5x squared minus 8x plus 15. That's the dividend. I'll make a little note. That's the dividend. And the divisor is x minus 3.
If you're using lined paper, polynomial long division, you might wind up using a whole lot of lines if it's a real long problem, like this one here, 1, 2, 3, 4, 5, 6, counting the remainder, 7 lines. But with synthetic division, it's always, if you're using lined paper, 3 lines. It doesn't matter how long the problem is, 3 lines is all it's going to take.
I'm going to skip this line right here. The first thing I have to do is determine my k-value. The k-value is the number you get that would make that divisor equal 0. When does that divisor equal 0? 3. So we're going to use a k-value of 3. K equals 3.
It's just writing it out, showing the pattern.
And then I put a little hook there, something to separate it from everything else that I'm going to do. Then I make sure the dividend is in descending order based on the power, and it is x cubed, x squared, x, and finally a constant, no x. You write the coefficients of the dividend. The x cubed coefficient is 2. You know, it might be helpful if you go ahead and write out up here at the top, x cubed, x squared, x, and I'll put a c for constant. The coefficient of x cubed is 2. The coefficient of x squared is negative 5. The coefficient of x is negative 8. The coefficient of the constant, the constant itself, pardon me, is a positive 15.
So counting the labels, it's going to be 4 lines.
Oh,
If
yeah.
you count the x cubed, x squared, the red, it'll take 4 lines in this paper.
I draw a horizontal bar, I skip a line, and I draw an equal bar. To get this process started, the first thing you do, you bring down the leading coefficient. 2 comes down. Then you go 2 times 3, that's a positive 6. Negative 5 plus 6, that's a positive 1. Then you repeat the process. Positive 1 times positive 3 gives me a positive 3. Negative 8 plus 3 gives me a negative 5. And you repeat until you run out of columns. Negative 5 times 3 is a negative 15. 15 minus 15 gives me a 0. This last number is the remainder. The last number is the remainder.
And now at this point, the answer, the quotient, is staring you in the face.
Realize what you're taking. You have a 2x cubed, and you're dividing it by x. Here's my scratch word. 2x cubed, and you're dividing it by x. Well, we could cancel an x above and below. What are we going to have there? 2x squared. Your leading term, the 2 is the coefficient. That's that red 2 right there. The variable part is 1 less than what the degree started, the divisor started with. It started with an x cubed, so you're going to have a 2x squared. Then you move across, decreasing by 1. Instead of an x squared, you have an x to the first. Instead of an x, there's no x. Your quotient, the leading exponent, is 1 less than the biggest exponent in the quotient. The dividend. So the quotient would be 2x squared plus x minus 5. Using the division algorithm, says that quotient.
Wait, I can't see.
The division algorithm says quotient times divisor is equal to dividend. So if we were inclined to do so, here's the quotient. We can multiply it by x minus 3, combine all the like terms, and once we do that, what would we get? We'd get the dividend, 2x cubed minus 5x squared minus 8x plus 15.
Now let me pull up the...
Look back at that picture. We did the exact same problem. What did they get? Does our answer match theirs?
What's their answer here? Well, this is where the quotient is. 2x squared plus x minus 15.
No, minus 5.
Minus 5. And their remainder was 0. Is our remainder 0? Yeah.
Mm-hmm.
Okay. It takes just a little while to get that pattern down. Figure out what k is.
And remember, k is the number that makes the divisor 0. Now, let's be more specific, though. Since in order to use synthetic division, it just has to have a variable. It can't be a 7x minus 3, just an x. So when you look at this number, there's that number. I'm seeing a minus 3. How do you determine the k value? You change the sign. You see a minus 3. So the k value is a positive 3. Just like when we're finding the center of a circle in center radius form. The sign you see inside those parentheses is exactly the opposite of the sign of the center. So whatever you see in the divisor, change that sign. That number is your k value. Let's look at a problem from the homework, number 4. Let me write it down.
This would take a lot of work to do it with long division. Okay? But it wouldn't be that bad.
With synthetic division, it's not that bad, but it'd be time consuming with long division. Make sure I wrote that down correctly. 4x to the fourth minus 27x cubed plus 19x squared minus 8x plus 12, all divided by the divisor is x minus 6. Can we use synthetic division? If so, what's the k value? 6. It's just the opposite of what you see. So we're going to have a k value of 6. Oops. That is a cursive k. I accidentally reverted back to my cursive script.
After all those years of your penmanship awards, you've got to show off that cursive writing.
You should just jealousy never looks good on anyone, Tony. I do seem to think you may have won one.
I did win it 1 year.
Yeah, you did. You did win it 1 year for your class.
I was so excited, and they ran out of certificates. I didn't receive it. Literally. I didn't get it until 1 year later, after I told my mother and father, I'm going to get the penmanship award this year too, in my class. And they thought I was lying.
Oh, I don't think they did.
I think they thought I was just trying,
You were trying to
copy.
Okay, let's fill in the coefficients. We have the variable terms in descending order. And that brings up a good point. Suppose it went from x to the fourth to x squared. Suppose there wasn't an x cubed. What number would you write there in place of x for x cubed? Not 1. 1, that's almost right. It's close. 0. If a variable term is completely missing, you need a placeholder of 0. So fill in the coefficients. We have a 4. We have a negative 27. We have a positive 19. We have a negative 8 and a positive 12. And we draw the line. To get the process started, we bring down the leading coefficient, 4. Then you go 4 times 6 is a positive 24. Negative 27 plus 24 gives me a negative 3. Negative 3 times 6 is a negative 18. 19 minus 18, that's a positive 1. Positive 1 times positive 6 gives me a positive 6. Negative 8 plus 6 gives me a negative 2. Negative 2 times positive 6 gives me a negative 12. Oh, this is nice. What's the remainder going to be? Another remainder of 0, okay? There's the remainder. I'm going to put a little r there.
I like r equals.
I put a little r equals to indicate that's the remainder. What's the variable part for this for this 4? We started off with the next to the fourth. X cubed, right. X squared, x, and finally no x. Here's our quotient.
Oh, don't sigh.
Oh,
Oh, wow, you know, it's pretty bad. Oh, wait, let's see. Yeah.
4x cubed minus 3x squared. I won't bother typing that 1 in front of the x minus 2. I'll just write a plus x minus 2. But MyLab would count it correct if you typed that 1. So, let's see. Start typing it in.
4x
Cubed
cubed
minus 3x squared.
right arrow minus 3x squared. Get out of that exponent. That's why I hit the right arrow.
Plus x minus 2.
Plus x minus 2. I'll check this answer after I move this over here. Okay.
Any questions? Let's go back to number 3.
Yeah. Oh, this one's a multiple choice.
Oh, that's nice. Okay.
And look at how they write the remainder. So they just say R9. I would like to see R equals, but that's not. So it looks like either it's going to be a negative 9 or a positive 9 as the remainder.
Let me write the problem down. 2b cubed plus 14b squared plus 18b minus 19 divided by, I feel like making the division symbol in a different color, b plus 5.
Yeah.
What's the divisor in this case? Can we use synthetic division? Remember when using the old-fashioned division symbol, the divisor is the second thing, and so yeah, I think so. It's the thing that comes after the division symbol. That is in the form variable, plus or minus a number. So let's determine our k value. Negative 5, I agree. Remember, it's exactly the opposite of what you see in that divisor. You see a positive 5, the k-value is a negative 5. The k-value is the number that makes the divisor equal 0.
Yeah, I like that.
Okay, so we have a b cubed, a b squared, a b, and then a constant. Now we fill in the coefficients. I'm waiting.
2, 14,
I agree.
18, and then a negative 19.
Okay, good. Then we skip a line, draw our equal sign. What do we do to get this process started?
2.
You bring down the 2, I agree. And then what do you do with that 2? Okay, 2 times the k-value negative 5 gives us a negative 10. 14 minus 10 gives me a positive 4. And then
4 multiplied by negative 5.
Gives me a negative 20. 18 minus 20 gives me a negative 2. And we repeat it again. Negative 2 times a negative 5. We keep repeating the process until we run out of columns. That gives me a positive 10. Negative 19 plus 10 gives me a remainder of negative 9. So our remainder is negative 9. The remainder is negative 9. What's the variable part for this b right here? B squared. It's one less than the biggest exponent in the dividend. So we have a b squared and a b. I'll put a comma there before the remainder equals negative 9. Do y'all remember that terminology? Something goes evenly into something. A number divides evenly. That means that the remainder is 0. For instance, 2 divides evenly into 8 because 8 divided by 2 is 4 with no remainder. Dividing evenly means the remainder is 0. Divide evenly means the remainder is equal to 0. So we say in number 4, x minus 6 divided evenly into the dividend, but b plus 5 did not divide in evenly. So let's, oh wait, is this multiple choice? This is multiple choice.
Yeah.
Okay. So when I'm using that terminology, such and such divides evenly into something, that means the remainder is 0.
Oh
So,
gosh, which one is it? They all look alike.
It's not A because the remainder is a negative 9. 2b squared plus 4b. It's not B. Maybe it's C. No, it better be D. Is it D?
Minus 2.
2b squared plus 4b minus 2, remainder of negative 9. Okay. Now switch over to this paper. I'm going to make up an example. Let's suppose we had the function, I don't like variables of b. That's one of those things I've told you. If I ruled the world, those b's start looking like 6s to people. So if I ruled the world, the first rule would be that the variables x, right? X would be the required variable, provided you're only working with one variable. Now, if you need additional variables, you can use W, you can use an A or a C.
B. Well, no.
No, I don't want to use a B because it looks like a 6.
Yeah.
So
what about an S?
S, no, that looks too much like a 5.
Yeah.
So, but anyway, that's beside the point. Here's my function. I'm making up a function, and I'm going to use the variable x for it, okay? The function is 2x cubed plus 14x squared plus 18x minus 19. Here's what, suppose I told you I'd come in here today and said, okay, here's a pop quiz. Here's the function. I want you to find f of -5. What does that mean? What does that tell you to do?
Solve the x.
Okay, so everywhere there's an x, you're going to plug in a -5.
Could y'all do that easily without a calculator?
Probably. Maybe.
I mean,
You
you could
can
do
do
it
it.
without a calculator, but maybe not easily.
Okay.
Okay.
It would take a little break.
I think I'll punch it into the calculator.
Yeah, punch it into a calculator.
Yeah, I'm always
Let's
wanting to
see.
pull up my calculator, and you're always wanting to not do it. Okay.
I just don't like it when it's in the way of what I'm writing.
2 parentheses,
-5
In order to cube, I hit this little caret top, cube. I'm
Plus.
typing in what I have right here.
plus
Plus 14, parentheses, -5,
There's a point to all of this.
squared, plus 18 times -5 minus 19. So I plugged a -5 in for x, and look what we're going to get.
I think we're getting a -9. Now,
What
wait
is
a
that
minute.
point? Well, there was another -9.
We saw another -9. Notice this function, it's this function here. I just changed the b's to x's. 2x cubed plus 14x squared plus 18x minus 19. It's the remainder. There's something called the remainder theorem. If a polynomial is divided by a divisor in the form variable plus or minus a number, then the remainder will be exactly the value that you would get if you plugged that k value in to the dividend. Now, that's called the remainder theorem. Let me see if I can state it a little clearer.
Imagine back in the olden days before calculators.
If you go pick up some algebra book from the 30s and look through it, you'll see.
Yeah, they're going to see so many of them.
Yeah,
But
yeah.
if you did,
You'd see synthetic division all over the place. It turns out back before calculators, oh, I need to plug in a -5 and cube it. Well, you'd have to do that by hand. But what's quicker, trying to do this by hand or set up this little tableau with synthetic
did
division?
we need a calculator here?
When I was going through this synthetic division, did we need a calculator? Did we use a calculator? Did we even have any exponentiation going on? Down here, we have to start off with these exponents.
Negative
was there
5
any
times -5 times
exponentiation?
-5 is -125 times 2 is -50.
-250.
-250. What did I say? 150?
No, you just said -50.
Oh, gosh. Okay, then here, -5 squared would be 25
okay.
times 14.
Do we have any exponentiation in this this synthetic division tableau? No. That's what was nice back in the olden days when they were trying to evaluate functions at specific numbers. Unless it was just a linear function that was real easy to plug into, they'd use synthetic division. And then whatever that last number was, that's what the value of the function was. So let's see.
Wait, just to re-emphasize what you're saying, like if you were going to plug the number 6 into this top stuff here.
Say I took the k value of 6. I needed to plug it in here. Without going through the evaluation, what would we get?
If you plug the 6 up
0.
here,
The remainder is the value of the function when you plug the number in. You would get a 0 there. Come back over here. Suppose you needed to plug 3 into this top. What would you get? A 0 as well.
it was a lot easier back in the olden days to use synthetic division rather than doing it all by hand. Okay?
Okay,
So,
let's see. The remainder theorem, I'm going
I'll
to
just say
say.
remainder equals f of k.
Okay, the remainder is equal to f of k.
Yeah.
That's a nice brief way of saying it.
And
Now,
number 5's going
that
to make
really,
sense.
I should mention something. There's in this day and age, the remainder theorem isn't really that important, okay? Because if I need to plug in -5, I can just plug it in using a calculator. No problem, okay? So the remainder theorem has lost some of its significance just because calculations are easier thanks to calculators now. But back in the olden days, that thing was really important. And if you look through the coordinating board on higher education undergraduate manual, and you go to mathematics and you look up college algebra to see what is the teacher supposed to be teaching. One of the things that is specifically listed as a learning outcome is they name it the remainder theorem. We're supposed to teach y'all the remainder theorem. Well, there's something called the fundamental theorem of algebra. The fundamental theorem of algebra, surely that's important, right? The fundamental theorem, that sounds important to me. Did that fundamental theorem of algebra get listed as a learning outcome for college algebra? For any algebra class? No, it did not.
It's sort of funny.
It's sort of funny if you think of, that's when I go back and I think that the people deciding on these outcomes, the people we elect and send to Austin, they may have never taken college algebra. They're going through looking, what are we doing? Looking through, what's done in college algebra courses, and someone sees the name remainder theorem, and they know, the remainder. That's what you have left over when you're dividing, the remainder theorem. They need to know how to divide. And that's how the remainder theorem got stuck on there as a student learning outcome. Is it significant today? No, not really. But let's do a problem with the remainder theorem, specifically designed for the remainder theorem.
Number 5? Okay.
No, it's you went to number 6.
Oh, wait, I think it is
5.
Oh.
There it is. Yeah. Let's write it down. They give us a function, a rather messy function. F of x equals -x cubed minus 8x squared minus 12x plus 9. They give us a k value of -6. They say use the remainder theorem and synthetic division to find f of k for the given value of k. So they want us to find f of -6. That's what we're looking for.
But instead of me getting my calculator and punching it in,
we're going to use synthetic division. They've already given us the k value. We don't change the sign. They've told us k is -6. So I'm going to set up.
Wait, let me show your writing.
There's k is -6, and I have, what's the biggest exponent? X cubed, x squared, x, and finally my constant. I fill in the coefficients, and this is what Angelina was thinking of earlier when I said suppose a term is missing, what's the coefficient? And I wanted y'all to say 0. And Angelina, she was thinking if the coefficient. I know what you were thinking. You were thinking if the coefficient was missing, then you assumed what? A 1. Okay. So right here. Negative. What's the coefficient? -1. Here. -8. Here. -12. And finally here. 9. Then we draw a line. What do we do to get the process started?
Remember how to do this synthetic division?
What do we do?
Drop the negative.
Okay. And then you go -1 times -6 is a +6. -8 plus 6 gives me a -2. -2 times -6 is a positive 12. Negative 12 plus 12 gives me 0. 0 times negative 6 gives me a 9 plus 0 gives me a remainder of 9.
And which number here is the answer?
9. If you plug negative 6 into every one of those x's there, you would get the answer 9. That 9.
So why don't we just plug it in?
We could have,
Oh, you
on
could
a
have.
test, you could just plug
Plug it
in,
in.
okay? As I said, the remainder theorem is not
It'll never
as
not
important.
add up. Like,
Let's see, but if you're going to plug it in, you make sure, okay, you have a
make sure you-
negative right here, so I hit negative, and then in place of the x, I put a negative 6 in parentheses, and you're raising a negative number to a power. It has to be in parentheses,
oh, that is
and
good.
just calculate
Oh,
it.
no, let's see.
This is good.
Mhm.
Square minus
I mean, it's
12
fine.
times
It's
negative
just
6.
the exponents on the calculator.
And
plus
plus
9.
9. And we better get a 9, or else I've messed up, or he's messed up. There it is, a 9.
There it is.
Okay.
Sure enough.
But be careful. If you don't have these negative 6s in parentheses, you're going to get the wrong answer.
But notice there's no exponentiation when using the synthetic division. Suppose you needed to plug in a negative 17. That would really be time consuming here.
Yeah.
Well,
But
I thought
using synthetic division,
just on that first number 4, I mean, just plugging in a 6. 6 to the 4th. 6 times 6 is 36, times 6 is 216, times another 6 is 1296 times 4. And then the messy one, minus 27 times 6.
cubed.
So that's 27 times
Okay.
216. I can't do it in my head.
Okay. Okay, some terminology. You gotta write stuff now, okay? This is a definition. K is a 0, and in parentheses I'm going to write root. When we were in school, these things were called roots. But when you think of roots in terms of math, you think of square roots and cube roots. This has nothing to do with those things. So the new accepted term, I guess it switched over in the 90s. Seemed like all the books switched over to the term 0. K is the 0 of a polynomial function, p of x, if and only if p of k is equal to 0. A 0 is a number that you can plug in to the function, and the function equals 0.
Like, is k equal negative 6 a 0? No.
Because when you plug in negative 6, you don't get 0. And that's another thing. Another way of stating this definition, instead of saying p of k is equal to 0, you could say the remainder
Is 0.
is 0.
Why don't you
Look
put that
over
in
here.
as a parenthetical expression?
I'm going to put in a little parenthetical expression. Remainder is equal to 0. So look over here. Let's see. Is negative 5 a 0? If you plug negative 5 into that dividend, did that give us 0? No, it gave us a negative 9, didn't it? What about 6? Is 6 a 0 for the dividend? If you plug 6 in, would you get 0? Yes, the remainder is 0, so you get 0. So in this case, 6 is a 0.
And
Or a
that's what-
root. And I think I've
I
broken
like
my...
the that terminology rude, because to say 6 is a 0, what?
Okay. Or, hey, what about 3? Is 3 a 0? Yes, because the remainder is 0. If you plugged in 3, you get a value of 0. So there's some other stuff I need to state. Okay. K is a 0. Means that when you plug the K into the function, it equals 0. We have something called the factor theorem. It says if K is a 0, then X minus K is a factor. That means X minus K divides in evenly with the remainder of 0. Look over here to illustrate that. K was a 0. 6 was a 0. That means X minus 6 is a factor. If it's a factor, that means it divides in evenly with the remainder of 0. So it should be obvious if K is a 0, then X minus 6 has to be a factor. X, in this case, X minus K, in this case, X minus 6.
Maybe we should mention where we're going with all of this.
Our goal is to have a way of factoring higher order polynomials. That's the whole purpose of this assignment. So far, when we factored polynomials this semester.
Oh, wait. What did we say the answer was here? I never punched it in.
What was that?
Was it 9 or negative 9? 9? Okay.
What are you looking at?
That number 5 that you
okay,
did.
9. Yeah,
okay.
I punched that in. Okay. So let's see. Look back when we were factoring at the very beginning of the semester.
Oh, okay. Let's just
No,
show them that here we're going to start factoring x cubes. Up to this point, all we factored were quadratics.
That's what I'm looking for.
Oh,
let's see.
Right out here, we started factoring quadratics.
Okay, remember we were factoring quadratics. We had the variable squares. We hadn't factored a cubic. We hadn't factored something with a variable
The natural question would have been if somebody asked, how would we have done this if there'd been an x cubed? We would have said, you wait until you know how to do synthetic division. We'll show you then. Okay? And that's what we're going to do with number 6. Why don't you, I think last time you wrote it.
I wrote that.
Oh, I think you did the example and then wrote out your strategy from that.
Mm-hmm.
Oh, okay.
That's what
So you ready to do number 6?
I'm ready. Number 6
says to factor f of x into linear factors. Well, all they really needed to say was factor. When we factor stuff, the stuff in the parentheses is always linear, okay? So
2x cubed plus 3x squared minus 62x plus 105. We want to factor 2x cubed plus 3x squared minus 62x plus 105. And notice they're telling us that k equals 3 is a 0.
They give you the k value, so there's no change in sign here. Okay, wait. Let's make sure everyone's caught up with this. Stand down in case anyone's still trying to write down what you've written. It's so bad out here.
I know, it does.
That's why I keep moving it over to try to cover up some of that mess.
I don't think that really matters.
So what we're going to have here is a way of factoring stuff with a bigger exponent than just x squared. When there was an x squared, when y'all were factoring quadratics, how many sets of parentheses did you have in your answer? For quad 2.
Good.
Now,
with the next cube, how many sets of parentheses do you think we're
if you're going to follow the pattern, x squared has 2, x cubed will have 3. If we're factoring something with an x to the 4th, how many parentheses? 4. You can expect the number of parentheses to be the biggest exponent. So On 6, 7, and 8, we're going to factor stuff that has an x cubed, so our answer is going to have 3 sets of parentheses.
I'm going to write out something right here, okay? I'm going to write, here's the space. This is terrible. I'm going to run out of room, aren't I? Well, okay. Here's where I'm going to write my final answer. That's where I'm going to write my final answer, the factorization. They tell us k equals 3 is a 0. If k is a 0, then we know what the factor is. It would have to be x minus 3. So that's going to be one of the 3 factors in our answer. Variable minus 3.
X minus 3 will always be a factor, or x minus k.
X minus k. Well, suppose k was a negative 3. Then you won't have a minus. What would you have? Remember at the beginning I said the number you see, that k value, is exactly the opposite of the divisor. The divisor and the factor are the same thing. We need 2 more sets of parentheses. Let's get started. We use synthetic division. We have our k value of 3. And we have an x cubed, an x squared, an x, and a constant. And we have those coefficients, 2, 3, negative 62, and 105. Let's skip a line. So first thing I do is, bring down the 2 times 3 is a positive 6. 3 plus 6 is a positive 9. 3 times 9 is a positive 27. Negative 62 plus 27, is that a negative 35?
Yes.
Times 3 is a negative 105. 105 minus 105 gives me a remainder of 0.
Should we be shocked by that?
We knew this number was going to be 0 because we were told k equals 3 is a 0. If you use synthetic division and you get something other than 0, then you can't get it factored using that k value, okay? We'll discuss that in more detail in a moment. But for the time being, we've broken down f of x. We know one of the factors is x minus 3. The other factor, okay, we started with an x cubed, so that's an x squared and an x. There's the quotient. X minus 3 times 2x squared plus 9x minus 35 should equal 0.
Can y'all factor this stuff here and get 2 sets of parentheses? So that's how you get the other 2 sets of parentheses.
We know how to factor 2x squared plus 9x minus 35.
Well, the
First times first has to give us 2x squared. I can only think of one pair that would give us a product of 2 using positive integers. What is it? 1 times 2, so you have a 1x times a 2x. Oh, what do we know about the sign? The last sign's a minus, so what do we know? A plus and a minus, so we'll wait to fill that in. Now, 35. What times what gives us 35? There's not that many possibilities. We could have a 1 times 35 or a 5 times 7. I don't think it's going to be 35, 1 and 35, because if we used a 35 in either place, 35 times 2 is a 70. 35 times a 1 is still a 35. That's way far off from that 9. So I'm thinking we're going to have to use a 5 and a 7. So let's
play around with it. How do we arrange the 5 and the 7?
Is the 5 going to go in the first set or in the second set? I think the 5 is going to go in the second set there. So we have a 14x and a 5x. Okay, 14 minus 5, that'll give us a 9, but how do we need to arrange the signs in order to get a plus 9x? You tell me what's going to be in front of the 7, the plus or the minus? Plus, and then the minus. I agree. So here's the factorization. X minus 3 times x plus 7 times 2x minus 5. So if we had the time, we could sit here and start foiling. Foil x minus 3 times x plus 7. That would give us an x squared plus 4x minus 21. We would then distribute a 2x through all of those terms. We distribute a negative 5 through those terms. We'd combine like terms, and guess what we would get? 2x cubed plus 3x squared minus 62x plus 105.
Wow. And
Any
what's the
questions?
alternative?
I know there's a lot to think about here, but by using synthetic division, we can break the polynomial down, the higher order polynomial, until it's just a quadratic. And we know how to factor a quadratic. That's that reverse FOIL or trial and error. We know how to get, if we know a 0, we know how to get the third factor. It's just variable, and then the exact opposite of the 0. The 0 is a positive 3, so we use a minus 3.
So would it always be factorable, or would we ever have to use the quadratic formula?
Well, if this thing is not factorable, then it can't be factored in terms of linear factors. So yes, the trinomial, that was a good question. The resulting trinomial for these problems all have to be factorable. Maybe you don't see the factorization, okay, but they have to be factorable.
The fact that it says factor into linear factors, that means
you can only have x's in the parentheses.
Okay.
Type in the answer now.
Oh yeah, I forgot about that.
And then I have something else I want to make a point of.
So
I could ramble on about this stuff for literally class meetings. I really could.
3
X minus 3 times x plus 7 times 2x minus 5. Okay. Now, there's something, let me ask you something. We already know, if instead of them saying to factor this messy thing, if they had said find all of the zeros. We know 3 is a 0. If you plug in 3, it'll make that thing equal 0. There are 2 other zeros. Well,
negative 7.
okay. When is x plus 7 equal to 0? When x is negative 7. When is 2x minus 5 equal to 0? When x is equal to 5 halves. So once you have it in factored form, you can determine the other zeros if you needed to. Just set each of the factors equal to 0 and solve. The fundamental theorem of algebra, that thing that I think is important that was never even mentioned by name in an algebra class. If this were, say, something like geometry, I could understand them not listing the fundamental theorem of algebra as a student learning outcome.
They listed remainder
The remainder theorem, something that has no relevance in modern society. Why? Oh, somebody that didn't know much math was like, oh, remainders. They knew remainders. That's what you had left over when you divided. Students need to divide. Oh yeah, let's add the remainder theorem. I guess that's what happens when you start having some people that don't necessarily know that much algebra decide what we're going to teach in these algebra classes. But the fundamental theorem of algebra says that the number of zeros cannot exceed that largest exponent there.
Like quadratic equations have 2 answers.
Yeah, when you're solving a quadratic equation, you expect there to be 2 solutions. Well, you may have the same solution twice, but you can't have more than 2 solutions. When you're solving a 3rd degree polynomial, you can't expect there to be more than 3 solutions. And in general, the number of zeros cannot exceed the biggest exponent. That's what the fundamental theorem of algebra says.
Instead of talking, you want to do some writing and write out a strategy on how to do this, how to factor into linear factors?
Just for a moment.
Oh,
Just
okay.
talk loud for a moment. I'll be right back.
Oh, okay. So let me write out a strategy. How to factor into linear factors. How to factor a polynomial into linear factors. Y'all are only going to have third degree, x cubes, okay? Well, first you have to be given a k value. If you're given that k is a 0. First thing, x minus k is always one of the factors. And as he did in the example, we generally write that down first. Okay? X minus 3 was one of the factors. He wrote that first when he did it. Then, use synthetic division. Let's use synthetic division. Factor the quotient to get the other two sets of parentheses. Oh, I can tell I did not win a penmanship. I did not win many. Okay, so just sort of summarizing what we did there. Okay. Now, you might be sitting there thinking, well, wait a minute. This all depends on being told k equals blah is a 0. What if that wasn't given? Don't worry about that yet. It's actually amazingly simple to find a 0 like that, and that's what we'll do for the last few problems. But 6, 7, 8 are like this. Let's do number 7. Okay? Let me write it down.
Can you go back to the...
Oh, to what?
To the rules?
Oh, this?
Yeah.
Oh, yeah. Okay, so read out how I wrote it up then. See if you agree with this.
Given k is a 0, x minus k is always one of the factors. That's right. Use synthetic division, then factor the quotient to get the other two sets of parentheses using trial and error.
Yes.
The thing that you'll get when
Go
you use
ahead and
synthetic division will be quadratic. And so when you're
Maybe
factoring,
a
you're
little
going to use
parenthetical expression, use trial and error.
I'll say use trial and error. It's there.
Okay. Gives me a chance to write all of that down while I take a drink of my hot tea. I used to drink iced tea, but I'm always so cold in here. Those of you with hair don't know. You lose 40% of your body heat from the top of your head. So,
Also the bottom of your feet.
Yeah, but I have shoes on my feet, okay? So for us, the problem is...
I have a beanie I could wear, but I just think I look too stupid wearing a beanie up here. Okay? So, are we ready to do number 7? I think number 7 might be a little tricky because it doesn't say, like here it says k equals. Let me see, on number 7, it doesn't say k equals. It just says -3 is a 0. You got to know that's k equals -3. Okay, so write it down. Number 7.
Number 7. F of x equals 4x cubed minus 9x squared minus 58x plus 15. And they tell us that -3 is a 0. That means k is going to be -3.
Write it as k equals now.
I'm going to. I was the one that told you to
Yeah.
write it like that, okay? I remember years ago when I walked by your class and I saw you weren't using K, you just write the number there. And I was like, oh no. That's okay. K equals -3 is a 0. K equals -3 is the 0. We're trying to factor 4x cubed minus 9x squared minus 58x plus 15.
I like
So,
your answer line that you wrote a while ago.
f of x equals. Here's where we're going to write the factorization.
How many sets of parentheses will we have in our answer?
3, because that exponent there is a 3. We're factoring them into linear factors, so there should be 3 sets of parentheses. So, what's the factor we get from that k value? It's x plus 3, right. It's exactly the opposite.
X
Okay.
minus k, x minus a negative would be x plus 3.
That's right. X minus a -3 becomes x plus 3. Just remember what you see inside the parentheses is exactly the opposite of the k value. Now we'll use synthetic division. And we have an x cubed, x squared, x, and a constant. Y'all call these numbers out across there that I'm going to write. Here, 4, -9, -58, and 15. And I skip a line. Here, what number am I going to write here? 4. I'll bring down the 4 here. Four times -3 gives me a -12. Down here, -9 minus 12, -21.
Oh,
Okay.
you're adding -9 plus a -12, -21.
-21 times -3 gives me a,
Positive.
that'll be a positive. So that's 63. What's -58 plus 63? It's going to be a positive 5. What am I going to have here? -15. What will I have as the remainder?
0.
And if I didn't have a 0 here, I know I've messed up.
But since you
Because
got
they
a
told me that -3 is a 0. So I have to have a remainder of 0. Variable part on the 4, x squared, here, x, and finally a constant. So we have to factor 4x squared minus 21x plus 5. Oh, I know something nice about the signs.
Can you put like equal 0?
Oh, yeah, you can if you want to write. If you
Oh,
want to
wait,
go through the
right
equation.
here,
Yeah.
if you want to write it as, no,
R equals.
that's R equals. That's the remainder. You can
Yeah,
say
but-
remainder
But if she
equals
wants
0.
to say she's solving an equation, you could sure write equals 0.
But then you can't put those numbers there. You have to type in the set of parentheses, okay? So I think she's saying right here equals 0. No, I'm just going to put remainder 0. What do we know about the signs inside the parentheses? It's something nice. Okay, good. That last sign's a plus, 2 negatives, there and there. And for 5, that's mighty nice. 5, there's only one pair of positive integers. What is it? 1 times 5. Now for 4, there's 2 possibilities. 1 times 4 or 2 times 2. I suppose the first the inclination is to jump to the 2 times 2, but I can tell that's not going to work.
Let me fill in the 1 and 5 right now.
Okay, the 1 and the 5.
That's all.
I need a negative 21 there. Well, if I multiply 4 by 5, that's going to give me 20. And then I'd get an additional 1 here. So I think that we need the 1 and the 4, not the 2 and the 2. If you play around with 2 and 2, you'll see it doesn't work. So let's try what are we going to need in order to get a 21? Are we going to have a 1x here or the 4x? What do you think? When you're multiplying that outer to get a 20, I think we need the 4x there and the 1x there. Y'all check me with that. What's the outer product? A negative 20x. What's the inner product? Negative 20x minus 1x. Does that give us negative 21x? Yes, it does.
Way back, months ago, in January, you mentioned something, and I thought, oh, why is he saying that? That's going to be way over their head.
But I made the remark that if that middle number there only differs by 1, when you multiply those numbers there, the 4 times 5, that's 20. This thing differs by 1. It's 21. Try using 1 in the number. More times than not, that'll work.
Yeah. Like if it had been a 19, it would have been 1 less. Try the 1 and 4 and the 1 and 5. And I thought at the time, oh, Tim, well, that's a stupid rule to be telling them. But actually, no. Actually, it's a really good one.
4x minus 1 and x minus 5. There's the factorization. This is what we're looking for.
Notice how we factor the x cubed into 3 linear factors.
And the order in which you type the parentheses, just like when you're factoring a quadratic, it doesn't matter which one you type in first. I always write the factor that comes from the k value, but you can type in 4x minus 1 first, and then the x plus 3. It'll still be counted correctly.
Let me do that. I'm going to type that middle one in first.
4x minus 1.
4x minus 1.
Then the x plus 3. Remember, multiplication is commutative. A times b will always equal b times a. So it doesn't matter.
What's the last one?
X minus 5. And if we knew 3 was a factor, negative 3 was a factor. If we wanted to, it was a 0. If we wanted to know the other two zeros, we'd set 4x minus 1 equal to 0. We'd set x minus 5 equal to 0. And
we'd have the 3 zeros. And how do we know there's only 3 zeros? Well,
what's the biggest exponent? There can't be more than 3 zeros, according to the fundamental theorem of algebra. Any questions there? So we now have a strategy for factoring higher order polynomials.
Wow.
Instead of just an x squared, if we have something with an x cubed, we have a strategy for factoring it. Now,
other than just trial and error. Can you imagine?
Just random trial and error.
How long would it have taken you to guess these 3 sets of parentheses if you knew, okay, I have 3 sets of parentheses, the first 3 terms have to multiply to give a 4x cubed.
X times 4x times x, that's the 4x cubed.
The last 3 numbers have to give a positive 15. Oh, wow.
3 times negative 1 is a negative 3 times negative 5. That gives you a positive 15. Okay, so but how do you arrange the rest of this stuff to generate a negative 9x squared minus 58x? I think that would be very time consuming. You know, the first terms in each parentheses have to multiply together to give you a 4x squared. The last times last times last has to give you a positive 15.
Oh, wow.
I don't think that's
It'd
very
take
much.
a very long time to figure that out.
There
For me,
is one drawback. There's one weakness to this factoring method. Has anyone figured it
I've
out?
already mentioned it.
Oh, you did?
Yeah, you gotta have that K value. What do you do if there's not a K value? Don't worry, it's easy to find them. But we're gonna do one more of these. Let's do number 8 all the way through. There's another factor. There's 3 problems here that we're gonna factor. And this one, once again, doesn't say K equals -8. You just gotta know when it says -8 is a 0, that's your K value.
F of x is equal to 4x cubed plus 27x squared minus 39x. Is that a plus 8?
Uh-huh.
And they tell us that -8 is a 0, so K equals -8 is a 0.
Let me show them how you've written it down. So, the instructions, the buzzwords that let you know that you got to do this is if it says factor into linear factors, blah, blah, is a 0. Going back to that student years and years and years ago, 30-something years ago, before y'all were born, saying his dumb teacher told him to study the instructions. Oh,
Yeah.
That's a really good idea. I'm going to start telling my students that. And I could tell. He disengaged immediately and thought, it's another one of those weirdo teachers saying, study the instructions.
Wasn't that at a...
That was at Bamboo Garden.
Mm-hmm. I was going to say the name of the
Well, I
restaurant.
think I've mentioned it in other videos.
Okay,
It's
y'all
a great
ready?
restaurant.
I'm writing my answer.
write it down.
Here's my answer line. F of x equals, and I'm going to have 3 sets of parentheses. We know one of the factors, it's a direct result of that 0. X plus A.
Good,
Exactly
good.
the opposite. Keep in mind, if you plug in that -8, it has to equal 0. That's why it has to be exactly the opposite, x plus A. We need 2 other factors. Here we go with our synthetic division. K equals -8. And we have an x cubed, an x squared, an x, and a constant. We fill in the coefficients across the top here. I'm waiting. 4, okay. Then we go across to 27. What else? -39 and then we draw our line. What do we do to get it started? Drop the 4 down. 4 times -8 is a -32. 27 minus 32 gives me a -5. I agree. Times -8 gives me a -39 plus 40 gives me a +1 times -8 gives me a -8. What am I getting for my remainder? 0. And I better have gotten 0. If I didn't get 0, then I messed up somewhere. What's the variable part attached to this 4? X squared. And then an x. There's the remainder. The remainder is 0. This thing right here, this is what we need to factor now. 4x squared minus 5x plus 1.
Oh, good.
I know. Okay, we know something very nice about the signs. Okay, the last sign's a plus, so you have 2 of those first signs, and we know something else. Look at that. What times what equals 1? 1 times 1, good. What, is that what you were saying good about?
Mm-hmm.
That the fact that it was a
It's
1?
both minuses and they're both 1.
Yeah.
Okay.
So 4x squared. What times what will give you 4? Well, a 1 times 4 or a 2 times 2. Hey, if you multiply 4 times 1, what do you get when you multiply 4 times 1? 4. Well, that's this number here only differs by 1. 5 minus 4 is 1. So I'm not going to try the 2 and 2 yet. I think we're going to need a 1 and a 4. Maybe a 1x and a 4x. Does that do it? Let's check. Let's check the outer product. X times negative 1 is, I'll get us started at negative 1x. What's the inner product going to be?
Negative 1x.
And negative 4x. What's negative 1x minus 4x? Negative 5x. Is that what we needed?
Yes.
Yes, it is. So there's the other two factors. X minus 1 and 4x minus 1. Here's what you'll type in the blue box. Here's the answer.
Y'all ready for me to type it in? So we will feel confident we got the right answer.
Once again, the order of the parentheses doesn't matter. X plus 8.
Oops. Plus 8.
4x minus 1.
4x minus 1.
And x minus 1. Now notice we're typing it in a different order from what we got when we're writing it out. The order of the parentheses doesn't matter. Just make sure you have the same thing inside all three sets of parentheses. Any
But the
questions?
plus has to be with the 8. The 1s have to have minuses in front of them. No.
Okay, suppose they hadn't given us a 0. K equals negative 8. Suppose they hadn't told us that negative 8 was a 0. In order to factor this thing, you need to know a 0. Well, you could just sit there. Well, let's try 5. Let's try 0. Let's try 10. You could just sit there trying different numbers until you find one that make it equal 0.
That would take forever.
That would take forever. But there's another approach. There's something called the rational zeros theorem. I wanted to call it the rational root theorem. Use that old terminology, root. The rational zero theorem what the rational zeros theorem does is give you a finite list of numbers that might be zeros, usually about 20 possibilities. So instead of just infinitely many numbers, you're trying to figure out what makes it equal 0. It gives you a list of usually no more than 20 possibilities. And if you needed to find one, you'd come up with that finite list of numbers, then get started. Do I plug in 1? Does that make it equal 0? If so, great, use synthetic division. If not, go on to negative 1. Just go through the list until you find one of those numbers that makes the thing equal 0. Here's what the rational zeros theorem says. Possible rational zeros.
And I think that'll be a buzzword in the instructions. Find the possible rational zeros.
Must be in the form plus or minus, it's a fraction. There's a plus minus there. That'll take care of the various sign changes. On the top, the number on top must be a factor of the constant term. Factor of constant term. In the bottom, has to be a factor of the leading coefficient.
This isn't something that's obvious. I wonder if any books still even go through trying to prove this. Probably not. Oh, no, I'm in college algebra. I don't think they try to prove that anymore. So it's factor of constant term over factor of the leading coefficient. Let me show, looking at this, remember, this is the constant.
The thing that doesn't have a variable is the constant.
And leading always means what?
The one that has the biggest exponent, the coefficient of the term with the biggest exponent, that 4 is the leading coefficient.
So you're gonna.
You know something? How about we go through using this exact problem from number 8 and find all the possible zeros. So you can see, suppose they hadn't told you -8 to start off with. What would you have had to do so that you could get to -8? Let's find the possible rational zeros of this function. We already know, from having already factored it, we know the rational zeros. When is x plus 8 equal to 0?
Negative.
At -8. When is x minus 1 equal to 0? Positive 1. When is 4x minus 1 equal to 0? You'd have to move the 1 over and divide by 4 to get a 1/4. So we already know the zeros. The zeros are -8, positive 1, and positive 1/4. Once we get it factored, it's easy to determine the zeros. Suppose you don't know a zero to start off with.
To number 8.
I'm going to.
That's fine.
I'm going to say example, and I'll say find the possible rational zeros of f of x equals, what was it, 4x cubed plus 27x squared minus 39x plus 8.
It's a little pattern that you'll follow to get these possible rational zeros.
I'm going to run out of room.
Oh, you want me to do it? I can do it with less room.
Oh, okay.
You start off, since it's the top term is the constant term, let's write out factors of, what is that constant term? 8? Constant term is 8? So tell me all the numbers that multiply together to give us 8.
And realize you only need the positive integers because that plus minus in the formula is taking care of the sign changes. So don't say -1 times -8, just the positive integers. There's 1 times 8. What else is there? 2 and 4? Any more? No? Okay. Now look at the factors of the leading coefficient. The factors of 4.
1, 2, 4.
Okay, 1, 2, and 4. I agree.
And now we're going to write every fraction in this form. Okay? We're going to take every one of these numbers and put them over every one of these numbers. So we start off, I'll write the plus minus, and then we're going to go 1 over 1, 2 over 1, 4 over 1, 8 over 1. 1 over 1 is 1. 2 over 1 is 2. 4 over 1. 8 over 1. Okay.
And that's a good, this illustrates something. Plus or minus 1 will always be possible rational zeros because 1 will always divide into the leading coefficient and the constant term. 1's always a factor for any positive integer.
So I'll put all of these numbers over 1. Now take all of these numbers and put them over 2. So I'm starting now. Plus minus 2 over 1. No. 1 over 2. 1 over 2.
2 over 2.
2 over 2. Wait, what is 2 over 2? I've already listed that.
So we can skip that. There'll be some repetition along the way.
Now, what about 4 over 2? I've already listed that. 8 over 2. Have I listed that one already? Oh, yeah, okay. Now, see why I only listed 1/2 when I was going 1 over 2, 2 over 2, 4 over 2, 8 over 2. Now, what am I going to do? I take each one of these numbers and put it over 4.
Okay.
1 over 4, I'll pick up right here with that plus minus. So we have 1 over 4. Then 2 over 4 is 1/2. I've listed it already. 4 over 4, 1. 8 over 4, 2.
In this case, there's only 12 possible zeros. If they hadn't told you a zero, you'd start off with 1. Does it make it equal 0? If so, then use synthetic division. And we would have gotten lucky. Was 1 a 0?
Yeah.
There it was. But
We also said 1/4 was a 0. Is it listed here? Yeah, positive and negative 1/4. So imagine out of all the billions and billions and trillions of numbers out there in the world, here's a list of 2, 4, 6, 8, 10, 12. These are the only 12 that could possibly.
make that function equal 0.
Well, do they all make it equal 0? No, only 3 of them. Here we have the actual 3. Negative 8, positive 1, and positive 1/4. Oops. Okay. But,
I think we better go on before we run out of, before we get timed out.
Oh,
Let's
okay.
do number
9.
9. Okay.
Here, and why don't you do number 9, writing out all the,
I will.
Jim will show the steps more than me.
Yeah.
That was one of those things. He was shocked when I didn't write out all the steps. Doing the rational 0, I'm just going 4 over 1, 4 over 2, like that. But the order in which you list these numbers doesn't matter. So, and sometimes, like on this problem, if you follow what we're doing, you'll know you'll be able to answer this maybe, or maybe not. Does the 6 and the 15 really have anything to do with it?
Come back, switch over here. Switch back. Okay. Suppose I'm going to change this little example we made up here. 4x cubed plus 27x squared. I'm going to change it to 127x squared. Instead of a minus 39x, I'm going to change it to a plus 39. Does that change the possible rational zeros? Do these middle terms have any impact on the list of possible rational zeros?
No.
No, the only numbers
constant?
you're using are the constant, and the leading coefficient. Those middle terms, they can be anything. It doesn't matter when listing the possible rational zeros.
I've seen students mess up because instead of doing the constant first, if I'd written factors of 4 before factors of 8, then no, I can't do what I was doing here. It's the constant over the leading coefficient. So I always do the constant term first. I assume that's how you always do it.
Yes. Okay, let's look back at the problem, make sure I wrote it down correctly.
Let me see.
And let's study those instructions. Find all possible rational zeros for the following polynomial. That possible rational zeros. That's what triggers you, or says you have to use the rational zeros.
And we deliberately assign multiple choice on here so that you don't have to type them all in.
But they also go through and they reverse it. So if you get confused and flip the things, it's going to be one of those incorrect, the distractors.
Yeah, make sure you're doing constant over leading coefficient. So
I look over here. I see the constant is a -8. We don't have to worry about that sign, though. The plus minuses are taking care of all the sign changes. All we need are the factors of 8. So that's That's not what we just used. What was it? 1 and 8 and 2 and 4. What's the leading coefficient? What's the leading coefficient? 2. So we need the factors of 2.
That's nice. Nice.
Yes.
There's not a lot of factors of 2.
They are 1 and 2. Now we're going to list out all the numbers that could possibly be zeros. You have to take every factor of 8 and put it over 1. Then you take every factor of 8 and put it over 2. So here we go. I'll do the
You're going to write it all out.
I'm writing it all out.
And like
Plus
what I
or
did.
minus. You put 1 over 1, 2 over 1, 4 over 1, and 8 over 1. I took 1 over 1, 2 over 1, 4 over 1, and 8 over 1.
And what he was trying to mention earlier is if you had reversed them and done factors of 2 first and then factors of 8, that'll give you one. They'll have that as one of the wrong answers on the multiple choice.
1/4,
Okay.
1/8.
Make
That'll
sure you're
be
doing
one of the-
constant first.
Constant goes
leading.
first, and then the leading coefficient. Now we take all of the factors of 8, and what did I say we had to put them over?
Put
We
them
put
over
them all
one.
over 1. Now we got to put them all over 2. So let's see. Well, I'm running out of colors. How about purple? Take it 1 over 2, 2 over 2, 4 over 2, and what's the last one? 8 over 2. We have to simplify because these fractions, there's repetition here, and some of the things are going to be scratched off. 1 divided by 1, that's just 1. 2 divided by 1 is 2. 4 divided by 1 is 4. What's the next one? I'm cleaning up this big list. 8 divided by 1 is 8. Now 1 divided by 2, that's 1/2. Do we have 1/2 listed yet? No. So we stick on the 1/2. 2 divided by 2, that's 1. Do we have 1 listed?
Yes.
Yes, okay. So we can scratch that off. 4 divided by 2. 2, do we have that listed?
Yes.
Scratch it off. 8 divided by 2 is? 8 divided by 2 is 4. Do we have it listed already?
Yes.
Wow, this one, there's only, 10 numbers out of infinitely many rational numbers. There are only 10 of them that could possibly make that function equal 0. That's really amazing. So if we needed to factor this, I'd start off with 1. If I plug in 1, do I get 0? If so, great, use synthetic division. If not, go on to -1. And I just keep on going. The worst thing that would happen is you go through all 10 of them, and none of them make the function equal 0.
Can't be
And
factored.
then it can't be factored. If none of these possible zeros make the function equal 0, then actually you know something. You would then know that the polynomial is prime. It can't be factored. And if it can't be factored, there can't be any rational zeros. The fundamental theorem of algebra says the number of zeros cannot exceed that exponent. But it doesn't say you can't have fewer. If that thing's not factorable, you're not going to get a rational zero. Any questions there? A, B, C, or D?
Now, the order here doesn't matter, so look. Okay, so 1, 2, 4, 8.5.
So the only fraction is a half.
Which one is it?
A.
Is it A? 1, 2, 4, 8. So they put a half right here.
I know what they do. What they do is they're taking 1, put it over 1, 2. Take 2, put it over 1, 2. 4 over 1, 2, 8 over 1, 2, which is just as right. I like to take the numbers on the top line and put them over the 1 and then the 2, going like that.
Because especially if you're doing it my way, the over 1 gets you all the ones that are not fractions right off. Okay?
Even my way, it gets all the
Yeah.
numbers that aren't fractions.
Yeah, but my way, since we're not showing the steps, it's
Let's look at number 10. I like number 10. People do weird stuff with number 10. No, that's not it. Go on to number 11. There's one for people do weird. Oh, yeah, this is it. Number 11.
same type of problem.
Find the possible rational zeros of negative 2x to the 4th plus 3x cubed plus 6x squared and a plus 18.
Did you write it down?
Yes. And we want the possible rational zeros. We want to find the possible rational zeros.
Why not write
The
out
PRZs.
Why not write out possible rational zero?
You're right.
There's no time they ever say find the
Possible.
PRZ.
Possible rational zeros.
Again, like that student said, you got to pay attention to the instructions.
Okay, so I'm going to start off by finding the factors of what number?
Are we going to do the 2 first or the 18?
18.
The 18.
18 first,
Got it.
because that's what goes on top. Well, that's 1 times 18, and 2 times 9. I think there's another pair. 3 times 6, I agree. And now we need, Tony's already jumped to the punchline. What's the leading coefficient? 2. Good. You see, you don't mess with that negative there. Only the number part. Because the plus minuses, that takes care of negative 1 times positive 2 and positive 1 times negative 2. All you need are the factors of 2. Here are the numbers we're using. 18 and now 2. Oh, and what are the factors of 2? Just 1 and 2. Okay, so here we go. You take all of these numbers here and put them over. You take all the factors of 18 and put them over 1. Then you take all the factors of 18 and put them over 2. So here we go with our PRZs.
That's something
Let's
new,
see.
Tim.
I used to do that all the time back in the old building.
Oh.
You take 1 over 1, 2 over 1, 3 over 1, 6 over 1. What's the next one? 9 over 1 and 18 over 1. And then we take all of those numbers and we put them over 2. So we're going to take 1 over 2, 2 over 2, 3 over 2, 6 over 2, 9 over 2, and 18 over 2. And now let's clean them up. That first row that I wrote, we can just drop off all those over 1s. So we have plus or minus 1, 2, 3, 6, 9, and 18. Okay, so we got those, what is that, 12 numbers. Okay, 1 over 2 is 1/2. Do we have it listed here? No, so we'll do what happened to our black pens, Tony? So we have a
I was absent a day and you lost them, Tim.
1/2.
You're not
2
sure
over
enough
2.
to keep up with your black pens. I'm not
Okay,
sure
that's a
you should
1.
do
We
this.
already have it. 3 over 2. Do we have it listed? No, we better list it. 6 over 2. 6 over 2 reduces to 3. We have it. 9 over 2. No. 18 divided by 2. That's 9. We have it. So here, out of infinitely many rational numbers, there are infinitely many rational numbers that can be plugged in for x there. The domain is all real numbers. There are only 2, 4, 6, 8, 10, 12, 14, 16. Here are the 18 numbers that could possibly make the thing equal 0. And so if you needed to, here's what I'm going to do. We're handling this the way our esteemed former colleague, Dr. Kirkendall, handled it. I'm not going to make you go through. There are no problems where, okay, factor the polynomial and they don't give you a 0. But if that were to ever happen, say you're at work and your boss comes in and says this thing needs to be factored, and they don't give you a 0. If they don't give you a 0, that's okay. You know the strategy. You use the rational zeros theorem to come up with a list of possible rational zeros. Then you start going through. Which of these numbers? Find one that makes it equal 0. If none of the lists make it equal 0, then it's just not factorable. There are no rational zeros. But once you find it 0, then you know what you can do. You use synthetic division to break it down
and factor
to get something that's, more easy to handle and can be factored by trial and error.
I'm not going to say that this factoring like this is going to pop up just over and over except as review problems.
Right.
But at least you have a strategy and you've seen a strategy and you actually have to go through a strategy on how to factor something with something other than an x squared. How do you factor a cubic polynomial? Okay.
Mm-hmm.
Any
questions?
Mm-hmm.
Oh, and I should mention, if it were, say, an x to the 4th, then you're trying to break the x to the 4th down to an x squared, well, you're going to have to find 2 zeros. You find 1 0, then that can break it down to a quadratic. But if it started off as x to the 4th, you'd have to find 2 of the zeros and use synthetic division twice.
Now, if they're at this point, they might have tuned you out. So I want to add that what he just said, you don't have to do in the class.
I'm talking that when their boss gives them a higher order polynomial and tells them to factor it.
Well, maybe their parents do. Or something,
yeah, before they can go out for the night, before they get their allowance.
Yeah, okay. Oh, gosh. Now, are we ready to stop this?
Yes.
Yes, okay.